Hello and welcome once again. As we have been learning and understanding that mathematics is the language of physics, and we have studied calculus, differentiation and integration, and we have seen how those can be applied in the physical situation when we learn physics. Now we'll take a leap forward to understand a concept very important and imperative: vectors. Now let's start with discussing something like, suppose I give you a grid map of a city, something arbitrary like this. Okay, now suppose you're stuck at a point A, your car is messed up, and you call your friend and ask that you have been just standing 3 kilometers away from his home or his place or office, and you want him to come and pick you up. Now your friend, suppose, is here at B and he's new to the town, so he would not get at what point you are. So you have to direct him so that he can reach to you. So you call him up and you say that you're standing 3 kilometers away from him, and will you please come and pick me? And then you hung up. So he would not be able to come to you if you just say that you're just 3 kilometers away from me. He have to call you back and ask for the direction. So if you say that the place that you are standing on, if you go towards east, and if you're following a convention of direction like this, north, south, west, east. Now if you ask your friend who is placed at B, so that he would start and march towards east half a kilometer, and then take a knot from the turning point and go, let's say, 1 kilometer, and then from the next point he'll just have to take a right, again move towards east, let's say 1.5 kilometer, and then he'll reach to you. So you have to direct to him, because direction here is very important. So from the practical usage point of view, if we just say distance, that is not enough. So we have to append direction to the quantity like displacement. Like we had a discussion before, difference between distance and displacement. 3 kilometers is just the distance, and if we attach direction to that, it becomes displacement. So the first, your friend have to displace himself by half kilometer towards east. So this 0.5 kilometer is just not enough. You have to append direction to this. So this is very important. Otherwise he can go half kilometer in any direction. And then you have to go, suppose 1 kilometer towards north. So this direction is very important. And then you have to go 1.5 kilometer towards east again. Now from this we can understand that certain physical quantities, they can be described completely only if we append direction to its magnitude. Only magnitude in a sense doesn't give us the complete picture, or there would be anomaly in that. So to describe a physical quantity completely, for certain physical quantities, we have to attach direction to the magnitude of that physical quantity. And those physical quantities which can be completely described with the magnitude and the direction, they are called vector quantities. Now parallel to that, we'll be defining scalar quantities. Now scalar quantities would be those which do not require direction with its magnitude for completely defining that physical quantity. So like for example mass, suppose if we ask if the mass of a body, of any body, is 5 kg. Now direction of that 5 kg is not required, or it doesn't make sense to give the direction of the mass of this 5 kg. Mass doesn't have any direction. Physically, for describing, for discussing, it's not required. Direction is not required. We don't attach direction to mass. Mass is in absolute sense, it's 5 kg. It is in no direction. Talking of direction doesn't make sense in these cases. So in such cases where direction is not required, magnitude alone can describe the physical quantity, those quantities are called scalar quantities. Similarly, if somebody asks what's the volume of your water tank and you happen to answer 5 meter cube. Now if we ask again, in which direction is this volume 5 meter cube? You'll say, excuse me? Because volume doesn't have direction. It doesn't require direction for describing the space inside the water tank. 5 meter cube is good enough. Similarly, what's your height? If you happen to answer 5 foot 5 inch, in which direction somebody asks, you'll say no direction, because height doesn't have any goddamn direction. So certain quantities require direction, certain quantities do not require direction. And suppose if you started from your house and you said, I went 5 kilometers away from my house. Now that 5 kilometers away from the house could be in any direction. 5 kilometers could be in east, it could be in north, it could be in northeast, south, southeast, in any direction. So in that, when we talk about displacement of a point from another point, apart from the distance, direction becomes important. These are vector quantities, quantities which does not require direction for the description. Those are scalar quantities. Now let's discuss certain vectors and certain scalars. Now vector quantities, as we have given the definition, those quantities which apart from the magnitude require direction for the complete description of the quantity, the physical quantity that we're talking about. Those quantities are called vector quantities. For example, displacement. Displacement, we had an elaborate discussion before, is a vector quantity, and I hope you very well understand this. Similarly, velocity, acceleration, all these are vector quantities because they have direction. The particular direction in which acceleration is, in that direction velocity will increase. So it's important to know in which direction the acceleration is. Force. Force is a vector quantity. Force has a direction. If you say I'm applying force to a block on the floor, it becomes expediently important to tell the direction in which the force you are applying, because if you're applying force in this direction, the block will move in this direction. If you're applying force in this direction, the block will move in this direction. So unless you tell in which direction the force is being applied, the other quantities like displacement, velocity, acceleration cannot be told. So it becomes important that we attach direction with force. So force is a vector quantity. Similarly, momentum. Momentum, if you don't know, momentum is a vector quantity represented by P. It is mass times velocity. We'll discuss this in great detail once we sweep from this topic, vector. We'll get into these things. But I think you by the knowledge of class 9th, you must be knowing momentum is mass times velocity. Now when we have when we define a physical quantity in the product of two physical quantities, mass is a scalar. Now velocity is a vector. Now a scalar multiplied by a vector is always a vector. So velocity is a vector that makes momentum a vector quantity.